Hello, everyone. I am Muhammad Faiz Abdul Rahman, and this is my friend Muhammad Rifaldi Robi. And today we are going to present to you about our project called Automatic Exhaust Fan. My role in this job description is circuit constructor, and my friend is a programmer and project report. So let me tell you what is it about. In most households in Indonesia, we usually use it in the bathroom. Exhaust fan function is to get rid of the excess moisture, humidity, odors, and other pollutants. It also can help to remove water vapor that has accumulated on mirror and walls. The problem is that usually people forget to turn the exhaust fan after they take a bath. This can lead to unnecessary electricity usage and can increase the electricity bill of the house. Thus, this project is made to reduce the electricity usage and for the convenience of its user, to make sure the exhaust fan is turned on when it's needed. And this project description is this project will control the exhaust fan in the toilet. The project will use a temperature sensor to detect the temperature in the toilet and peer sensor to detect whether there's a human in the toilet. If the temperature reaches a certain threshold, there is a human in the toilet, the exhaust fan will be turned on with a switch. This system is used so we can reduce the electricity usage for the exhaust fan that is always on. This project is to design an automated exhaust fan that can detect the person in the bathroom and the temperature rise in the bathroom. Also, so we can use the exhaust fan efficiently. Yeah, so in this project, we use Arduino because of the validity, feasibility, and reliability of it. The validity means that the Arduino is commonly used for the project like this. Also, it uses the language that close to C. Language as the language program, so it will be easy to understand and configure for us. In this project, we use Tinkercad for the project simulation because in the Tinkercad, it has Arduino Uno as the microcontroller. For this project, we use first Arduino Uno, second peer sensor, third temperature sensor, fourth LCD display, and fifth DC motor to simulate exhaust fan, five breadboard, last but not least resistor 220 ohm. I will tell you about each of its function. So in this project, Arduino is act as the microcontroller. Arduino is used because of the validity, feasibility, and reliability of it. The validity means that the Arduino is commonly used for the project like this. Also, it uses the language that outflows to C language as the language program, so it will be easy to understand and configure for us. In this project, we use Tinkercad for the project simulation because in the Tinkercad, it has Arduino Uno as the microcontroller. And to see LCD display, we use I2C LCD display to show the temperature of the bathroom, to show whether there is someone in the bathroom or not, and to display the exhaust fan condition. As for the peer sensor, this sensor functions as to detect whether there's a human inside the bathroom or not. And the temperature sensor is to detect the increase of temperature inside the bathroom. So we can also know that the humidity is also increasing, as usually is that the bathroom air temperature increasing is due to the humidity that is produced while bathing. We use DC motor to simulate the exhaust fan inside the bathroom. The DC motor will only be turned on by high or low status, as the temperature sensor and peer sensor is acting as a switch. We use breadboards for this project because the ground pin and 5-volt pin in the Arduino is not enough. So we resolved to using breadboard to accommodate all of the components. And last but not least, 220 ohm resistor. This resistor is used for the I2C LCD display.
So yeah, move on to the next section. We will explain about how the program will work or the system. So as my friend already said that this project will have two sensor. The first one is PIR sensor to detect a human, and the second one is the temperature sensor. As the exhaust fan, we will use DC motor instead to simulate the condition of the fan. So yeah, as we can see that the PIR is connected to the pin 6 of digital pin, while for the temperature sensor is connected to the A4 analog pin. And for the actuator or the DC motor, it is connected to the 7 digital pin or digital pin number 7. So yeah, as we can see from the void setup, the PIR and the exhaust fan is set as input and output respectively, and we have serial begin 6900. So as we can see the result in serial monitor, and we have LCD begin to start the LCD. So if we start the simulation, this is the void setup for the first LCD. It will show the startup, and the content is our name. So in the first state, if we first turn it on, the only condition that is available is the state of temperature and the state of fan, because there is no movement yet in the PIR sensor. So if there is a movement in the PIR sensor, the LCD will display it. So we will move to the next, the first condition. The first condition, if the TMP value is equal or greater than 35 and the PIR state is high. So it means that the temperature meet, did I'm sorry, did reach the threshold of the sensor, which is 35 degrees Celsius in this case, and the PIR state is high because there is someone in the bedroom or there is a movement that detected by PIR sensor. So if that's the case, the fan will be turned on, as we can see from the DC motor, and the result of this condition will be displayed by I2C LCD display. And the second condition is if the TMP value is low, below the threshold, and there is no movement in the PIR range sensor. So it will display in the LCD, there is no one. This is the temperature, didn't meet the threshold, 35 degrees, so the fan will be turned off. Because we set it, because the exhaust fan is digital, right? We set it to low state, and the DC motor stop turning. And the last state is, or the last condition, if the TMP value is still below the 35, but there is someone in the bedroom. So yeah, this is the last condition. So the fan will be still turned off, but the LCD will report to us that there is someone because the PIR sensor detect the movement inside its range of reach. So yeah, that is all from us from group 6. Thank you.